Okay, so we ran the traditional lab, which, sometimes traditional labs help us understand some core concepts and learn some basic skills. So we don't necessarily always want to think them as always terrible or always bad because we can get a lot of good things out of them. But we can also supplement some of this with technology. So I'm going to show you how to use the Excel for the graph. So these were the numbers that were called out during the video. Now what I want you to do is I want you to make a plot with these. So what I'm going to do is I'm going to highlight both values. I don't need to get too terribly fancy with them. So I go under to insert, and when I look at the different type of charts, this one I see is a scatter plot. I can pick out different ones, but let's go with the scatter plot. Now, this is pretty neat, showing me what it would look like graphing. There are some important skills to do this by hand. It's up to you deciding on how you want to do this. If I click on the data points and I go on a right click, I can do something that's what's called a trend line. This is, in essence, a fancy name for your line of best fit. Now, it goes through a lot of the points, but I noticed that it seems kind of weird in that this one down here doesn't, the 0 point doesn't seem to work for some reason. And I want you to think about it. Why is it, even if you look at the data, it's like 70 centimeters, and then like, oh, well, now this one's 50, and this one's around 50, this one's maybe 60. Why did that first one take a little bit longer? Well, think about it. When the metronome started going, and I started the stopwatch at the very first time, and this at the same time as I let the car going, there's a little bit of a delay from when my daughter heard the sound and then she went to put it down. So there was a slight delay. She didn't actually put that first one down at 1 second. So what we can do to rectify this is the following. I don't always have to have everything starting at 0, 0. I could have it start out here. So I'm going to make a new set of values, but my first data point is not going to be 0, 0. It's going to be that 0.68. So what I'm going to do now is I'm going to graph these. So again, I go to insert and I go to scatter plot. And so here's my new chart. Now, if you want to, you can, make up fancy names with it, different ones. I'm not going to go and do that. But again, if I click on the trend line, now it looks a lot neater. Yeah, we got 1 point that was a little bit off, but for the others, they were pretty much spot on in how they were in terms of how fast it was going. And sometimes I might be like, oh, well, this one was a little bit too fast. Didn't quite put it at the right spot. Great lesson to talk about um, data analysis and errors in data and why we use the slope of a line of best fit because it kind of averages out all those errors. Now you can also put in the equation. So if I look on here, you see how I had the trend line items come up on the right. One of these says display the equation on the chart. And what I get is y is equal to 46x. Well, you might remember the equation y equals mx plus b, where m is the slope of the line and b is your y-intercept. Well, this mx is 46.5x. That's the slope. A slope, this, my y-axis, is position. This, my x-axis, is time. So change in y over change in x, change in position over change in time, that is your speed. This car moves at about 46.5 centimeters per second. And that's how I know what the speed of the car is. So that's a way that you can calculate the speed of the car. So you can go ahead, do some of the rest of the lab or just look at the lab a little bit and focus on this worksheet. Thank you and have a wonderful day. Bye-bye.